This is R.D. Sharma solution, class 12, chapter 11. The differentiation exercise is 11.2. Differentiate x square plus 2 divided by under root cos x. Now assume the first one, the numerator to be u and denominator to be v. So this kind of question we have already done. So if you just want to skip or you want to do it by yourself, I have presented the answer also. But those who want to learn how this is being done, you have to use the quotient rule. And quotient rule is which we have done already a lot of questions using this quotient rule. So this under root cos x whole square will be cos x only. Then this under root cos x will come here. Then a differentiation of d by dx of x square plus 2. X square plus 2. Then we have a subtraction. And this x square plus 2 will come in front. And then we have d by dx of under root cos x. The differentiation of x square plus 2 is going to be 2x. Differentiation of under root cos x will be 1 by 2 under root cos x, and this cos x, because we are applying the chain rule, cos x will be minus sin x. Now let us replace this here. What do we get? We get 2x into under root cos x, and then we have subtraction x square plus 2, and minus minus will become plus, and this is going to be sin x divided by twice of under root cos x. Twice of under root cos x. Okay. Now we can simplify it. This is what we have done. There is no differentiation left. There is just simplification. So let us take the LCM. 2x, so 2 to 4x, under root goes. So 4x cos x. This is going to be x square plus 2 sin x. And then in the denominator we have twice of under root cos x. The twice under root cos x will be in the denominator. So we can combine them because cos x was already there in the denominator, remember? So under root cos x to the power half and cos x to the power 1, that is going to be cos x to the power 3 by 2. Well, we will be changing it, but as of now it is cos x to the power 3 by 2. So now let us separate them because there is a plus sign. So let us separate with the same denominator so that we can simplify them. And that is going to be, if something is common, then also we'll take something common. So when you take this 4x into cos x divided by twice of cos x to the power 3 by 2. This will be your first term. Then second term will be x square plus 2 sin x and divided by twice of cos x to the power 3 by 2. Okay. Now this cos x, you can bring it in the denominator. So cos x to the power 1 will become cos x to the power minus 1. So 3 by 2 minus 1 will be, as we just did, half plus 1 is equal to 3 by 2. So this can be written as 3 by 2 minus 1. So it is going to be half. This is going to be under root cos x only. And this we have finally 2x by under root cos x. So here we are getting nothing like that. But what we can do with the cos x is, again we can write this cos x as same as like under root cos x and cos x. So under root cos x minus cos x is going to be cos x to the power 3 by 2. Alright. Now sin x by cos x becomes 10x. And under root cos x is in the denominator. You can take it outside, 1 by under root cos x. This is 2x plus, this is going to be x square plus 2. And then we have a tan x here. And then we have twice of, because under root cos x we have already taken out. This is the final answer. Differentiate this term. Now I'll show you the solution that you will be tempted to do, you should do. But I will give you a different solution because the answer may vary in terms of viewing perception. but they are ultimately same. What does it mean? See, we have to multiply this x square with 1 minus x square, because if you are going to do it like that, you have to apply the product rule. So we have so much complication here, so we will try to minimize the computation. Better is to multiply this x square with 1 minus x square. So when you multiply x square with 1 minus x square, it will be x square minus x to the power 4. So this is u, this is v, u in the numerator, v in the denominator. In the denominator you get x, this cos 2x to the power square, that is in the denominator. We have cos 2x here, d by dx of this whole, x square minus x to the power 4 minus this term goes here, x square minus x to the power 4. Then the differentiation of cos 2x will be minus sin 2x. I'll just show you the differentiation of both of them. First, let us differentiate the x square minus x to the power 4. It is going to be 2x minus 4x cube. You can take 2x common from here if you want, just to make them simple. So it will be 1 minus 2x square inside. 1 minus 2x square. Okay. This is the differentiation of x square minus x to the power 4. So 2x into 1 minus 2x square. And then we have a cos 2x already here, cos 2x. Then minus, this is x square minus x to the power 4. X square minus x to the power 4. And differentiation of cos 2x we have to do. I am just rechecking it because you will be finding some difference in the answer. But the process and the procedure remains the same. So d by dx of cos 2x is minus sin 2x. So 2x will be 2 because product this question rule followed by the chain rule. So we have plus 2 sin 2x and x to the power square minus x to the power 4. In the denominator we already have cos 2x whole square, that is cos square 2x. So let us write it in the denominator of both these terms. This is cos 2x whole square. This is also cos 2x whole square. Alright. This is whole square. So this cos 2x, 1 gets cancelled in the first term. So this you can write it as 2x into 1 minus 2x square. Cos 2x you can bring in it up in the numerator. It will be sec 2x. So this is twice. And this is going to be, now sin 2x and 1 cos 2x can be combined, because cos 2x whole square is cos 2x into cos 2x. So 1 sin 2x with cos 2x will be called the tan 2x. And this is going to be x square minus x to the power 4. You can just directly write it, or you can take something common from here. You can take x common. I'll take all of it common. That is 2 sin 2x cos 2x. One of these will I've written already. 1 cos 2x will remain. This cos 2x, when it goes up, it will be sec 2x. This is the inversion of cos 2x. It will be sec 2x. Now what is remaining when you take x outside from x square minus x to the power 4? It is going to be x minus x cube. Now sec 2x, let us take common. Sec 2x from here. This is 2 also you can take common. So 1 minus 2x square, it will be inside. This is the first term. Since we have taken 2 from here, x from here, and tan 2x will remain, x minus x cube. So you can write it as x into 1 minus x square. That also you can write. This is your final answer. Okay. Now what I am trying to suggest here is, if you see the answer which is there in the RD SHARMA, and this way which I have done, there is no difference. I just made a step easier. Otherwise the first numerator has to be, whenever you have a d by dx, you have to apply the product rule for x square and 1 minus x square. I just liberated you from that extra step. Next is log cot pi by 4 plus x by 2. So this is cot theta basically. So log of anything will be 1 by that thing, 1 by that thing, that is. So 1 by whatever is there inside log. It is going to be cot. This is pi by 4 plus x by 2. This is 1 by cot of this. And then we will be applying what? The cot of, because this we have to apply the chain rule. So cot of this, differentiation of cot of this term is going to be, because cot theta differentiation is minus cosec square theta. So whole of this with minus cosec square. So you have minus cosec square, and then you have inside pi by 4 plus x by 2. Now you have to differentiate pi by 4 plus x by 2 also. We have to go until no differentiation is left. So the differentiation is 1 by 2. Okay, this is your final. But let us try to minimize and simplify it. We don't keep it like that. So we have minus half. So let us write this minus half. Okay, cosec square pi by 4. Let us assume it to be some theta. So 1 by cosec square is, this cosec square is 1 by sine square. And cot is cos by sine. So this is cos, this is sine. Now you can cancel this 1 of the sine, and since there is already a twice here, so 2 sin theta cos theta or 2 cos theta sin theta is sin 2 theta. In the denominator you have sin 2 theta. So what we have is minus 1 in the numerator, and this sin twice of pi by 4 plus x by 2. So when you multiply 2 with pi by 4 plus x by 2, it is going to be what? See, I am going to multiply, this is pi by 2 plus x. I have already multiplied 2. So sin 90 plus theta is cos theta. You can just write it as cos theta, because in second quadrant the sign is positive. So you have minus sec theta, cos goes up. Differentiate e raise ax sec x tan 2x. Now you will learn in this question how to differentiate when you have in multiplication more than 2 terms. When you have 2 terms, you just directly apply the product rule. But here we have more than 2 terms. We have actually 3 terms. So it can be 3, 4, 5, n number of terms. So the way we actually do or solve this kind of question, any of one we take 1, and the other 2 we take them again as one term. So e raise ax d by dx of sec x tan 2x, then sec x tan 2x and d by dx of e raise ax. Alright. So this, I will do the differentiation of sec x tan 2x. We will be applying the product rule again. So sec x d by dx of tan 2x plus tan 2x d by dx of sec x. Okay, so this is going to be sec x. Tan 2x will be, you know that tan, what is the differentiation of tan theta? It is sec square theta. So just write it as sec square tan x. And differentiation of sec x is sec x tan x. So tan x is sec square, this is sec x, sec square 2x, and differentiation of 2x is going to be 2 only. Alright. Then you have tan 2x, differentiation of sec x is sec x tan x. So this is just the differentiation of sec x tan x. Now we have to multiply this whole with e raise ax. Alright. And then we have another term also, which is plus sec x tan x d by dx of e to the power ax. So let us write it here. I am just now putting the differentiation of sec x tan x along with all the other term. And what is the differentiation of e to the power x? It is e to the power x, and differentiation of ax will give you a. So a e to the power x. So essentially you will get a e to the power x sec x tan x. E to the power ax, and you have twice sec x sec square 2x plus tan 2x 2x and sec x tan x. Then we have plus a e to the power ax sec x tan x. Sec x tan x. Now what you can do here is, you can take certain thing common. E to the power x from here, and then you can take sec x, sec x, sec x from here. So what will you get? E to the power x, sec x we have taken common. Whatever is remaining, just write it here. So I am just cancelling those things so that there is no confusion. What all is remaining, let me write it here. It will be twice of sec square x, this first one I am just cancelling it, plus tan x, tan 2x. This is going to be your second term. And then you have a tan x, tan 2x, this is third term. So again, let me tell you that this question is all about when we have multiple terms in multiplication and you have to apply the product rule on it. Differentiate log cos x square. What is log theta or log y? 1 by y. So we have 1 by cos x square. Now you have to differentiate cos x square. Cos x square you have to do. Cos is minus sine. It is going to be minus sine x square. Then we have to do the x square. 2x. X square differentiation is 2x. So sine x square by cos x square is tan x square. This is tan theta only. Sine by cos is. So you have 2x tan x square. And this is quite very straightforward kind of question. So this is how you are going to write in your exam or your classwork. Same thing with just a small twist. There is no special thing here. Just cos theta is sine theta. The differentiation of cos theta is sine of log x whole square. Sine is cos, cos is minus sine. Remember. So sine log x whole square. Then we have to differentiate the log x whole square. It will be twice of log x. Twice of log x. And because y square is simply 2y. Differentiation of this is. And then log x is what? 1 by x. Okay. Right. Please remember cos is minus sine. So I am just putting the minus sign. So final will be minus, this is 2 log x, then we have sine log x whole square. So this just write sine log x whole square. In the denominator you have x. This is your final answer. Differentiate log of this under root x minus 1 by x plus 1. So this kind of question we have already done. So if you just want to skip, you can skip. But I'll just, as a sake of completion, log of anything will be 1 by that thing. So when this 1 by under root x minus 1, under root x plus 1 will go, this under root x plus 1 will ultimately go to the numerator. What I am trying to suggest here is, log of anything will be 1 by that thing. So this under root x plus 1 and under root x minus 1 will come finally, because under root x plus 1 will be going in the numerator. Now differentiation of under root x minus 1 and under root x plus 1. So this is going to be anything in the root will be 1 by twice of that thing. 1 by twice of under root of that thing. So you have this now. Now d by dx of x minus 1 by x plus 1. So let us see what do we get here of the first two terms. Again under root x plus 1 is going to go up. So we have under root x plus 1 in the numerator. Again under root x plus 1 in the numerator. It's under root x minus 1 in the denominator. Under root x minus 1 in the denominator. 1 by 2. Under root x plus 1 whole square, that is x plus 1 only. Under root x minus 1 whole square, it is going to be x minus 1 only. 1 by 2 will remain. And this one. So what do we get? This is, we will use the quotient rule here. So x plus 1 whole square will be in the denominator. Then we have x plus 1 here. Differentiation of x minus 1 will be only 1. I hope you have a fair idea now. And minus x minus 1, differentiation of x plus 1 will give you again a value called 1. Okay, so you get x plus 1 minus x plus 1. X gets cancelled. You get 2 divided by x plus 1 whole square. Now 2 this gets cancelled. X plus 1 gets cancelled. You have in the denominator 1 by x plus 1 into 1 by x minus 1. a plus b, a minus b formula, that is a square minus b square. So you will get 1 by x square minus 1. So this is how you have to write. This is the way you have to actually write in your examination. I told you how to do this. On the right you see how to do this, left you see how to write. This question we will take in the next discussion. Till then, thank you so much and take care of yourself.